detection and classification with convolutional neural networks. So the problem statement is finding and classifying house numbers in images. So this is a two-part problem. The first part is finding the numbers in the images, so localizing and drawing bounding boxes around those digits. And the second is classifying those digits. So given a bounding box and a part of the image, determine what number it is. And then at the end, combining those individual digit predictions to determine the house number in the image. The data set is 32 by 32 RGB. I've only used the type 1, which consists of about 70,000 single-digit images for training and then 26,000 for testing. For detection, the framework is as follows. So first I apply a median filter to get rid of any noise in the image. This is especially important for blob detection. Next, I use MSERT to identify blobs. So that gives me a list of bounding boxes, some of which are redundant. I use non-max suppression to remove those so that we have a more unique set of blobs. And then lastly, we apply a rule-based filtering method for finding the digits, which comprises of the classifier confidence, the aspect ratio, as well as are they near any other bounding boxes. For classification, 3 models were trained. So VGG with random weights initialized, VGG16 with ImageNet weights, and a custom ResNet model. In terms of training, I use the Atom Optimizer, which is essentially RMS-prop with a momentum stochastic gradient descent. Loading rate started at 0.001, and then it decreased if it plateaus for 5 epochs. For VGG16, I kept true to the original paper with dropout and L2 regularization. However, I did change the fully connected layers to 512 instead of 4096 because it was overfitting significantly with such expressiveness. And then after 50 epochs, the model with the lowest validation loss was saved as the final model. In terms of the custom model, it was based on ResNet 50 and then used identity shortcuts over 3 conv layers, and then there were 20 of such blocks. Additionally, it uses batch norm to normalize the activations. And then lastly, it does a global average pooling for dimensionality reduction and spatial pooling before sending it to the 10-dimensional softmax. So in terms of results, the custom produced the best result, even with a lower number of weights at 130 versus 130K versus the 15 million of VGG, and then the ensemble of the 3 produced the best. In terms of final pipeline results, it was fairly robust to scale and rotation and lighting.